Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Industry Best Practices for SSH Access. Our speaker today is Gus Luxton, who is Solutions Engineer at Gravitational. Hi, Gus. Thanks for joining me today. Really appreciate it.
Hey, it's good to be here.
Excellent, excellent. Well, I'm going to be here advancing the slides on your behalf, so just go ahead and give me a verbal cue whenever you need me to advance the slides. Otherwise, I'll put myself on mute and let you get to it.
Yep, no, absolutely. That sounds great. Okay, so hi everybody. As Charlene said, I'm Gus Luxton. I'm a solutions engineer at Gravitational, and today I'm going to be talking about industry best practices for SSH access. So just a little bit about me. I've worked at Gravitational for a couple of years. Before that, I worked at Facebook. I worked for a financial trading exchange in London, and I was a PHP developer. So I've done a little bit of everything. But I've kind of seen in estates of computers at various sizes, Facebook scale, smaller scale, kind of mid-range. So I've got some knowledge about these things, and I'd like to kind of share those things with you. Next, please, Charlene. Okay, so let's talk a little bit about why securing access via SSH is important. So managing access to servers traditionally in the past has involved sharing maybe a password and a username with somebody. You could do that via a password manager. You could write it on a Post-it note and give it to somebody. You could do all kinds of things with it. That's not particularly secure because anyone who has that password is able to authenticate with that username and get in. So we moved on to SSH keys. So SSH keys are very useful. You generate a key pair, you keep the private part yourself, and you put the public part on any service you want to access. And when you go to access them, you authenticate yourself with a cryptographic operation, and that logs you in. Now, if you want to use that on a bigger scale, you need to be able to copy those public keys around to multiple different servers. You might be able to automate that with Ansible or SaltStack or Puppet or any other kind of configuration management solution. But the problem with that is it doesn't scale very well when your organization grows. So to add new users, you have to rerun that process every time to add a new user's key. And then when someone leaves, you have to be able to remove their credentials as well. And it's important to be able to do those things within a short period of time. So that can make onboarding and offboarding pretty tricky. The other thing is that credential leaks and security compromises are a very real risk. If you write down that password on a Post-it note and leave it somewhere, anyone who gets access to it can use it. And even with a private key, if you put that on a USB stick and then leave that USB stick somewhere, anyone who finds that key may be able to use it. You can encrypt them, you can put passwords on them and that kind of thing, but you're still in a position where your credentials being compromised is a risk because anyone who has that key is able to log in as you. And then once you do have access via these methods, there's not a lot of visibility into what's going on. You don't necessarily know which key was used to log in, and you don't know what people are doing when they do connect. So that's some of the issues and some of the reasons why securing SSH is important. Next. Okay, so here's a summary of the things that I'm going to talk about today. So step number 1 is that you should switch from using public keys to using SSH certificates instead. It doesn't have to be hard. It's actually not too tricky at all. So we're going to talk about how to do that. Step 2, you should look at using a highly available Bastion host as an access gateway to your servers. Step 3, you should enforce the use for second factor for any SSH logins. And step 4, you should get your user identities from an external identity provider. Next. Okay, so step 1, switch from public keys to certificates. So here are some benefits of public keys. Public keys in general have much greater entropy than a shared password because they are generally 2048, 3072, 4096 bits long. They're very long values. So greater entropy means it's much harder for them to be cracked or guessed. In fact, it's pretty much impossible as far as we know with, even with the advent of quantum computing and things like that. At the moment, keys generally cannot be broken within a reasonable time frame, so they are assumed to be secure. You can't keylog a private key because nobody ever actually types one. Nobody's going to sit there and type out 4096 bits of value. They're all provided by files, so nobody ever types that in. They can't be keylogged. And as I mentioned just earlier, it's a cryptographically secure operation. So you are using the power of mathematics to authenticate that the person who is using a private key to access your server actually has that key in their possession. And that's a reasonable assumption that you can make. Next. So that was some of the pros of public keys, but here are some of the downsides of it and some of the reasons why you might want to switch from using them and use something different like certificates instead. So it can be hard to keep track of which key goes where. So keys, they don't expire by default either. So private keys by default are infinitely valid. If you add one onto a system and you forget about it, then you've given that person who has that private key perpetual access to your system until such time as you go and remove the public key so that they can't log in anymore. That's a bit of a risk. It's also hard to distribute the keys without building an external process to do so. So you need to put every single key that you want to provide access to on every single system that you want them to get access to. So you need to build some process for distribution. And let's be honest, we're all too busy to do that. Even if you have something like that already, you've got to scale it up. You've got to make it work for all of your machines. And generally fixing the problems with it is something that nobody really has the time for. So there's also a lack of accountability about which key belongs to who. So when you add a public key to a system, you can put a comment on it saying, oh, this is Gus's key, this is Jade's key, this is Charlene's key, whoever. However, that's just reliant on the fact that those values are set in the file themselves. You don't necessarily know that that comment is 100% correct. There's nothing built into the key itself to identify it. You're just relying on that comment being set correctly. And if someone were to go in and change that comment, you might lose track of the key. It also makes it hard to enforce credential rotation without building a separate process to do so. So the majority of people who use public key authentication, they just go and run SSH keygen once. They generate themselves a private key, which they keep, and then they copy that public key over to every server they want to access. And that pretty much stays that way forever. Sometimes people will go and regenerate them, but then when you do that, you've got to go and copy the public version over again. And, that's quite a tricky process. It's something that is risky. And if your keys are compromised or stolen, you've suddenly got a pretty big security breach on your hands. Next. So, certificates. They have all of the pros that I mentioned of public keys, and they don't have any of those explicit downsides. So, you add the public key of a certificate authority, the authority that issues all of your certificates, you add that to a server once, and then any certificate that it issues is valid from that point onwards. So if you're familiar with the concept of public key cryptography at all, for example, using web servers or anything like that, that is generally the same principle. So you have a certificate authority, you trust that certificate authority, and then any certificate that it signs is considered valid. You can add metadata to every certificate that you issue. So you could put in an email address or an internal username or some kind of internal ticket reference to your ticketing system, anything that you like, any reference that will make it easy for you to be able to track down those values in future. You can you can add any of those values you like. It's a free form field. And any time that that certificate is used to log in, those values appear as well. Certificates are easy to issue and easy to reissue as well. You can make them expire every 12 hours if you desire. It's that easy, and all you need is a quick process to issue a new certificate, and it works exactly the same way as before. So because you don't need to copy any of that data around to all your servers, you can just reissue the certificates as often as you desire, as often as you feel necessary. And that means that the shorter the validity of those certificates, the more secure you are, because any compromised credentials are only valid for a very short period of time, makes them not useful at all. You can also revoke the certificates by ID or by sequence number or by timestamp, anything like that. So it's very simple to make them invalid if you want to. And rotating credentials becomes much simpler. You can set up a brand new certificate authority if you want, start issuing certificates from that with a grace period, and that will allow people to get new certificates. Next. So here's an example of some metadata that's set on a certificate. So we can see here that this is an OpenSSH user certificate. We can see the public key that is used for it, and we can see the key of the signing certificate authority as well, which will authenticate that authority from all the others. We can see it has a key ID associated with it as well. So Gus at gravitational.com is that ID. You can set that to whatever you like. It has a serial number. You can issue the same certificate with a higher serial, and it will invalidate the older versions if you desire. You can set a validity period on them. So this certificate is valid for 24 hours, but you could make it whatever period of time you like. There's also, you can add extra metadata like principals, for example. So I've added EC2 user and Gus to this certificate. This can control which principals or Unix logins you're allowed to use when you log into a system. So that certificate will only allow you to authenticate as those users. Even if you put this on the system and you try to log in as root, the system will just block you and say, nope, you're not authorized to log in as root. And that means you can authenticate that and manage which logins people are allowed to use centrally. And there are other extensions on the certificate as well. So this one has permit X11 forwarding for graphical applications, older graphical applications. It allows the forwarding of an SSH agent. You can disallow that if you don't want people to be forwarding their agents all over the place. It allows port forwarding. It allows interactive terminals, and it allows you to manage a user RC file. So those are optional extensions that you can include on certificates as well. Next. So there's even more to this than that as well, because certificates, they don't just authenticate users to hosts, as in the traditional method, to say to a host, yes, I am this user. You can also use them to authenticate hosts to users. So has anyone seen a prompt like that at the top before? So fairly common with SSH. It's asking you to trust the key fingerprint of the server that you're connecting to. This model is called Trust on First Use, or TOFU, if you want a snappy short acronym for it. But it represents quite an insecure fundamental model. The problem is that most people will just type yes, as I did in the screenshot. They just type yes to that prompt. Originally, the idea of trust on first use was that you're supposed to go to some external source and you're supposed to validate that the key fingerprint that you're being presented is exactly the correct one. So you're supposed to go and look it up on the wiki or a central directory or something to say, yes, this is exactly the correct fingerprint for the server. And if it doesn't match, you're supposed to type no and disconnect and run a mile away from that host because you can't trust it. But in 99% of cases, people don't validate those at all, and they just blindly trust them. And if there's a malicious server behind that, you could be giving it credentials. You could be passing it details. This doesn't need to happen with certificate authorities because you can issue host certificates as well. So I can set up a host certificate authority, issue a certificate for that IP address there, and then I can put the fingerprint of my host certificate authority in my known hosts file locally. And then if I connect to a host which has that a certificate issued by that host certificate authority, I know that I can trust it because it's already been validated for me. So those TOFU prompts can be a thing of the past if you switch to using host certificates. And the message below as well, the remote host identification has changed. We've all probably seen that from time to time as well. And you have to go through and find the correct line in your known hosts file, go and remove it, and then reconnect and type yes again and that kind of thing. That doesn't have to happen if you use host certificates either, because of the fact that if you reissue a host certificate or you re-bootstrap the host, you put a new host there. This happens quite often with hosts behind load balancers. So if you have a load balancer with 3 hosts behind it and you connect to that over SSH, each of those hosts will have a different fingerprint, but the host name that you're using to connect will be the same. So those messages can be a pain. And host certificates can solve that problem for you as well, because you issue a host certificate for each of the hosts behind the load balancer from your host certificate authority, and all of a sudden it knows, your local SSH client knows, although each of those has a different fingerprint, it's all been issued by the same certificate authority, and you know that it can be trusted. Next. Okay, so we're moving on to step 2. So step 2 is the idea of using a Bastion server for access. So in an era of more remote work, we're all connecting to servers from different locations all over the place. Could be dynamic IPs, could be mobile data, could be hotspots, could be anything like that. This could be quite a nightmare to keep track of. Who is that user? Where are they connecting from? How can I be sure? How can I lock down my infrastructure to make sure that only legitimate users can connect? Whitelisting is pretty much impossible as far as I'm concerned. You can, with dynamic IP addresses, it's very unlikely that you're going to always know exactly what IP address your end users are connecting from, particularly with mobile data and things as well. So Bastion servers can be highly available. You can, as I mentioned before, you can put a few of them behind a load balancer. You can issue host certificates from all of them so you can authenticate them correctly. And then you can enforce that all of your users connect via that Bastion server. There's no need for a VPN. You can put the Bastion server out on the internet, because the only access that will be allowed to it is access using certificates that you trust. So given that certificates are cryptographically secure, you can be pretty certain that nobody's going to be able to get access outside of 0 days and vulnerabilities and things like that, which can be a risk, but largely mitigated. It doesn't have to be very difficult to set up access to a Bastion server either. SSH supports the use of jump hosts with the -J flag. You can instantly connect. From there, you can put all of your traffic through a Bastion server with just one extra flag to your SSH command, and everything will just work the way that you expect. You can add it into your configs. You can make your existing workflow work that way. It becomes much easier to block or revoke access when you know that all your connections are going to come from a limited number of Bastion servers, because you can revoke certificates on those Bastions and deny people access. You can terminate all their existing sessions. You can lock everybody out if you desire that. And the use of a Bastion server also gives a central location for logging and auditing access to your fleet of servers. The log files on your Bastions can be very valuable. You can see exactly who was connecting and when. You can do analysis on those things. You can ship those logs off to some kind of SIEM provider, something that will analyze your logs and alert on them for you if you desire. So those are some good reasons for using a Bastion server. Next. Step 3, how about enforcing the use of a second factor? So two-factor authentication is defined normally as requiring multiple factors from a list. So the list could be something you know, like a password, traditionally. It could be something you have, like an authenticator app or SMS, for example. And it could be something you are, like your fingerprint, a retina scan, an analysis of your voice, something like that. There is a star after SMS, and I'll get to that in a moment. You need to present 2 of these factors to be granted access. The likelihood that your password gets stolen, that's fairly reasonable, but the likelihood that your password gets stolen and you lose your finger at the same time, that's pretty small. It reduces the risk needing to provide 2 factors. And there's lots of flexibilities in ways that you can enforce this as well. So you can use TOTP, time-based one-time password applications, things like Authy, Google Authenticator, any of those kind of things. You're probably familiar with the model. You scan the QR code, you get a new code every 30 seconds. and then you type that in and that authenticates you. You can use push services like Duo, for example, Okta, Auth0, any number of other providers that do the same thing. Most of these have PAM or pluggable authentication modules available for Linux machines, so you can set up and manage all of those via your PAM config. The installation procedure is pretty simple. It doesn't take too much. Once you've got that set up, you do that on your Bastions and you're enforcing two-factor authentication. Authy also has a good solution as well that is a script that runs on SSH logins, and you can enforce two-factor via that as well. Now, the star after SMS that I mentioned as well, SMS authentication has some problems. It's actually not very secure at all because it's worryingly easy to take over somebody's cell phone number. If you can do some social engineering and convince a phone provider that they should port your number to a different provider, or they should give you access or anything like that, that means that SMS authentication is actually not particularly secure at all. So a word of advice, I don't recommend using it as a second factor. And if you do use it, I recommend switching to something else, because there's been a number of high profile attacks on all kinds of systems that have happened as a result of using SMS authentication. Next. So step 4, get your user identity from a third-party service. So do you really know who all of your users are? Could you make a list of all of them? Could you write them all down? And could you do that for 100 users, 1,000 users, 10,000 users? How easy is it to know exactly who all of your users are? And then what happens when a user leaves? You want to be able to revoke someone's access. But how do you know that you've removed all of their keys? This is the problem. You have a list of public keys, for example, on a server. How do you know you've removed the right one? You're relying on the comment on that public key being absolutely valid to say, yes, this is Gus's identity and I've removed it from all of the servers. But what happened if Gus put another key on there that you didn't know about with a different comment, and that stays? What if you have some other random key with a random name and you can't really identify that? How about a development VM that you don't know that exists? It's not something that and the key has been left on there, but it's still on the internet and someone could get access. All of these things are risks. They're all things that you need to evaluate. This is all something that you can attempt to avoid by using an identity provider as the single source of truth for all of your users. So if you put all of your users into an identity database that's managed outside, it could be something like Active Directory if you Microsoft users. It could be Okta, could be OneLogin, Auth0. You can even use something like GitHub. You add GitHub users to teams, and you can use that to say, yes, this user is a member of my team, and when you want to revoke their access, you remove them from the team, and then their access can be gone. That's one place to add users when they join and one place to remove them when they leave. So if you use this to create a process where you need to log in with an identity provider, and that allows you to then get a certificate, then you can embed the identity provider's identity, the email address, for example, of the user, into that certificate, and then use that identity for all access. And then every time that user logs in, you're getting that email address, that identity in your log file saying, yes, Gus at gravitational.com logged in with a certificate at this time from this IP address. And you've got all of that information available to you. If someone leaves, you remove them from the identity provider, and then they can't issue certificates anymore and their access is gone. Next. Okay, so summary of what we just talked about. So step 1, it's a good idea to switch from using public keys to using certificates for all the reasons I mentioned. Trust users from a central user certificate authority, and trust hosts from a host certificate authority. You could make your SSH experience a lot better by doing these two things, and it doesn't have to be difficult. I wrote a blog post, How to SSH Properly, that has detailed technical steps in about how to do this. If you're curious, just Google how to SSH properly, and all of the data is there. Step 2, use a Bastion host. So put all of your access through a limited set of servers and limit access to all of your infrastructure from those Bastion servers only. So configure your infrastructure to only allow access from the Bastions, set up a few Bastions, put them behind a load balancer, and then enforce all of your access going via there. Scales reasonably well. Step 3, enforce the use of a second factor. So allow users to add a second factor to their systems so that you can enforce they need a password and a token, or a password and a fingerprint, or anything else. 2 factors, always better than 1. And step 4, get your user identities from an external provider. So onboard your users in one central location and offboard them in one central location. That gives you good ideas to be carrying on with. Next. So how can you do this easily? Well, there's a few different ways. As I mentioned, I wrote the blog post, How to SSH Properly, detailing how you can do this with SSH Keygen and OpenSSH, open source PAM modules, any of these things. There's a great blog post there. If you don't fancy doing something like that, or you're curious about a project that would do it for you, give Teleport a try. So Teleport's an open source system. It's written in Go. It's been written by engineers for engineers. So Teleport tries to just get out of the way. It works well with existing SSH workflows. You can use an SSH client if you want to connect. It puts all of your access through a Bastion server. It adds identity provider via GitHub in the open source version, or by SAML or OIDC in the enterprise versions. It pushes access through the Bastion server, as I mentioned, and it uses SSH certificates internally. So it can set up a certificate authority for you, one for your users and one for your hosts. You can add all of your hosts into your fleet, and all of the access will be managed automatically. All of the fingerprints will be deployed for you. You can put that in your known hosts file and then authenticate that you trust your hosts. It doesn't get in the way. We're attempting to get out of the way. We want to just allow you to continue using SSH access and just get a certificate at the beginning of the day and use that. So that's a system that it works well. We use it constantly. It's something that you can do very simply, and it's fully compatible with SSH. So you can, all the certificates internally are SSH based. You can use SSH Keygen to view the certificates. You can look at all these things. So all your existing SSH based tooling will still work. It also has audit logging embedded, and it will allow you to write out to external providers, external databases, sources, all of these kind of things as well. Next. So we're pretty much at the end here. I've added some next steps here. So as I mentioned, the How to SSH Properly blog post, you can use that URL, or you can Google How to SSH Properly and all the instructions are in there. Give Teleport a try. We're on GitHub. You can go and read the code, go and look at it, download it, run it, give it a try, see what you think. We'd love your feedback. We're always curious to find out what people think. So with that, I think that's the end of my presentation. So we'll go to questions.
Excellent. Well, we are about 29 minutes past the hour, so we have plenty of time for question and answer period. If you do have a question, please go ahead and use your GoToWebinar control panel and submit your questions. Looks like right now we do not have any questions in, but I'm sure that's going to change very quickly. So while we are waiting to see if any questions come in, I do want to just remind the audience that today's event is being recorded. So if you miss any or all of it, or if you just want to listen to it again, you'll have the opportunity to do so. Okay, it looks like we've gotten a couple questions in here. Let's see. So let's see. The first one here is, how can we generate SSH activity log for monitoring?
So SSH by default logs a reasonable amount of data. So when you log in with a user certificate via SSH, or via a key, or with a password, SSH writes that information out to your SSHD log. And if you configure some process to get those logs and push them out to a centralized system, you can do aggregation with that. So you might use something like FluentD, for example. So FluentD can pick up log files and can ship them to a central destination like an S3 bucket or some other kind of centralized data storage, NFS, whatever you would like. You can so essentially pick up the SSH log files and push them to somewhere centralized, and then you can do analysis on them from there. Yeah.
Okay. All right, great. Next question here. So how can I exactly switch from using key to certificates?
So the exact details about how to do it, I didn't put like a ton of, kind of technical slides in this presentation with sort of commands and things like that, mainly because it would largely be echoing the stuff that I wrote in the How to SSH Properly blog post. So what I would advise is go and have a look at that. It's full of the commands, the SSH keygen commands, the modifications that you need to make to your SSH config and why you're doing them. It explains the flags that you're using and how you can modify them and things like that. So that's probably the best way to do it. But I'll give like a brief summary of how you can switch. To use user certificates for authentication, what you need to do is generate a user certificate authority with SSH keygen and some flags, and then you issue keys and you sign them with the user certificate authority. Again, SSH keygen commands, and then you change the config of your SSH daemon, so etc sshd config. You modify that to say, I want you to trust all certificates issued from this certificate authority, and you give it the public key of the certificate authority. You restart SSH, and then it will trust any certificates that people use to authenticate. You can provide a certificate using SSH-I, the identity flag on the command line. You can add them to an SSH agent, so SSH agent supports certificates as well. You can add them in and they'll automatically be used when you connect to servers. Again, all the detail of exactly how to do this is in the How to SSH Properly blog post. So go and read that, and if you have any questions, you can post on our Gravitational community forum and I'll be happy to answer them. Community.gravitational.com.
Excellent. Excellent. Okay. Gosh, we've gotten a lot of questions. And next one here. Okay. So wouldn't this be a burden to organizations? More tools, more setup, more learning curve?
I mean, I suppose any kind of change is a potential burden, but I guess the question is, which is a better situation? So you can continue with the current model of, if you're using keys, you can continue with that. But I mean, if the organization's never going to grow beyond 20 people, then maybe that's not a big problem. Maybe it is an acceptable amount of overhead, and maybe you do always know who's accessing your machines and you know exactly who's going to be connecting, and you can keep an eye on that sort of thing. So for smaller organizations, yeah, it might well be too much overhead. But for a larger organization, 50, 100, 1,000 people, when you get up to any of those kind of levels, it definitely, the management of SSH keys becomes more of an overhead. If you set up a process for issuing certificates, if it works well for one person, it can work well for 100 people or 1,000 people. And sometimes the benefit of that, the actual knowing that your certificates are only valid for a short period of time and issuing those things, that can be more beneficial than the overhead of having to set it up in the first place. Because once you've done this, largely it's a process that you don't need to do too many times, or once you've done it once, you know how to do it again. And it gets around a lot of the issues of syncing keys out to servers and having to run that every time you get a new user onboarding or a user leaving. So yeah, it can be overhead, but there's good reasons to do it in many circumstances.
All right, great. Plenty of time for questions, guys. If you do have one for Gus, just go ahead and use your GoToWebinar control panel and send it on in. Next question, do you have Terraform integration? So the question, I don't know whether the question's for kind of the blog post or for Teleport. I can answer for both. So in the blog post, it's just command line commands, how to do this on a one-off test machine basis, or how to do that kind of thing. You could theoretically Terraform these things. You could set up a machine for a certificate authority, for a centralized machine to issue those certificates and keep them securely. I haven't written an example about how to do that, but actually that's not a bad idea, and that could be a good way to extend the blog post to the future.
And I'll answer the question for the perspective of Teleport as well. So Teleport does have deployment examples for using with Terraform, for use with CloudFormation, for use with Ansible, for use with a variety of other tools as well. So yeah, it is possible to integrate or to set up Teleport clusters using Terraform. We've got examples for how to do that in our GitHub repo.
Excellent. Next question. What are popular ways of sharing short-living certificates? Email, Slack, something else?
Yeah, that's a pretty good question. So, I mean, ideally, the private key material that makes up a certificate, you don't really want to be sharing that outside of the user who's supposed to be using them. So what you would probably want to do to build a process for, you'd want to build a process for issuing certificates. So a kind of maybe a web UI or some kind of service that you connect to, like a remote procedure call type thing, a web service that you can, you set it up to log in and authenticate. And then when you've authenticated successfully, it generates you a certificate and sends it immediately back to your client machine. So you would generate that certificate and copy it down to your client machine using probably SCP or although there's a bootstrapping thing there because you need to be able to get access in the first place. So potentially, yeah, there's a few different kind of options or different ways to do that. Again, I don't want to sort of bang the drum about Teleport, but it does make this a lot easier. It has built-in processes for kind of issuing certificates, and it has a command line tool called TSH, which you can use to log into a cluster and get certificates, and it kind of manages and automates that part for you. Outside of that, to do it with SSH natively, you'd need some kind of access to the server that issues the certificates, or a kind of front-end wrapper to that, so a way to call the process remotely, like a script which connects for you and issues the certificate and downloads it for you. So ideally, you want to keep your private keys secure. I wouldn't send the keys themselves over Slack or something. You could if you really wanted to, but it's probably best to, you kind of lose the accountability then. If you share a key with somebody else, then you're not sure who's using it. It could be one of any number of people who it's been shared with. So.
All right. So many great questions. Next one here. Are there examples of Teleport being used with Ansible?
Yes, there are. Yeah, so we have some. So there's two different ways. We have some scripts. There's a number of open source scripts as well for or roles for installing Teleport using Ansible. There's quite a lot of those. If you Google for them, we have an example, I think, in our repo as well. So that's for kind of installing a Teleport cluster using Ansible. But then if you actually want to use Teleport to connect to hosts to run Ansible on them, you can do that as well. So Teleport will work. You can override your Ansible command. So in your ansible.cfg, you can override your SSH command. You can give it some common arguments. You could say run, SSH with a config file, SSH whatever. So you can use SSH natively, or you can use the TSH client as well. You should be able to run TSH, SSH. TSH is Teleport's internal kind of, own certificate issuing and SSH client. You can use that as well. But if you can set up your config files and run Ansible over Teleport-based connections as well. I've done that numerous times. It works well.
All right, great. Next question here, and you might have to help me with this one. How does this tool fit with having IaaC systems? I don't know if he means infrastructure as code or infrastructure as a service. Sounds like it, yeah. Yeah, okay, great.
Yeah, so it depends. I mean, if you have... So from a perspective of issuing certificates, you can absolutely use certificates for things like, if you have a Jenkins server, for example, that runs CI processes or some kind of centralized infrastructure as code system. I covered a little bit of that answer with the stuff about Ansible, for example. So you can use, if you're connecting to hosts via SSH, you can absolutely use user certificates for those as well. You can issue them, for a specific principle. So you could issue a certificate that only allows a Jenkins user or an Ansible user or a Puppet user to connect, for example. So you could issue a certificate which is designed exclusively to be used by automation, and which is valid for a short period of time. And you could integrate that with your process such that when the infrastructure as code pipeline needs to run, it first goes and generates itself a new certificate or requests a new certificate. You log that, and then that certificate's used for the duration of the connection. So that's from kind of a generic principle perspective. How can you do this with certificates in general? And again, yeah, from a teleport perspective, it can work with Ansible. It can work with anything that can use SSH as a transport. So you can issue short-lived certificates or longer-lived certificates if you want from teleport, and then use those with automation or infrastructure as code pipelines or things like that. You could also deploy clusters via a teleport cluster or a CA server or something via infrastructure as code as well, if you wanted.
Great. All right, guys, it is about 19 minutes to the top of the hour. There's still time for questions. If you do have one, go ahead and use your GoToWebinar control panel and submit it, and we'll keep plugging along until we run out of questions. Next question, very interesting presentation. We would like to use these mechanisms on embedded devices. These devices do not always have a correct time. Only sometimes NTP sync is possible. Can we use the system of certificates?
That's an interesting question. Theoretically, I mean, it depends how far your clock is out of sync. I mean, you absolutely can. So you can make certificates valid for as short a period of time, as little as a second if you want, or as long as years. They can be infinitely valid too if you want, although that does remove some of the benefit of using them, the kind of automatic expiry. So I think if you could assert that your clock would be accurate within a given sort of value, so if we're not talking that it's years out of sync or anything like that, you could still use them. It's just that if your clock was set to before the time that the certificate was issued at, then you might get a not yet valid type error. So it's definitely, it would be a harder problem to solve. I don't think it would be entirely impossible. You just have to, you'd have to establish a window for what your clock skew might be. Is it going to be 2 years in the past? Might it be 2 years in the future? And make sure that you issue certificates within that period. I mean, if you wanted to get really smart, you could even have a system where it would log how far the clock was out of sync for each of your individual hosts. And then when you issue the certificates, you could issue certificates from within a particular time frame. I don't know. I don't think that would work super well. I'm kind of intrigued about a situation where you wouldn't, I guess if you don't have internet connectivity all the time necessarily, then maybe NTP wouldn't be reliable. That's an interesting one, but yeah, definitely, if you had some idea of the time window, you could probably still use it, or you could make the certificates infinitely valid and you still get the benefits of allowing access only as certain principles, for example, or adding extensions in to say, no, you can't port forward with the certificate, or no, you can only run single commands, you can't have an interactive session. And you'd still get the embedded data about which certificate, so the identity, the email address, or the ticket reference, or username, or whatever that you have. You'd still get those benefits. So there's still some perks to using certificates, even if you can't necessarily rely on the expiry behavior.
Interesting. All right. Next question. Can you use PKI certs for GitHub?
That's like a more generic kind of question. So GitHub itself, actually, as far as I know, GitHub doesn't support certificate authorities yet. So if you set up a certificate authority and issue a certificate from it, you can't add that public certificate fingerprint to GitHub and have it work. I think I read a blog post from them a while back about how they want to add this, but it's kind of on the to-do list and it hasn't happened yet. Some things I know that do support it, Bitbucket, for example. So Bitbucket does support the use of certificate authorities and public key certificate or public certificate fingerprints. It does support that. I believe GitLab does as well. So maybe GitLab Enterprise. I think you can also use certificates there. So again, I mean, I wish GitHub would support it because it's a great use case and it's a brilliant, it would be a brilliant idea to allow that. But I just don't think GitHub itself, the hosted version of GitHub, the private version may have support for it, but I don't believe github.com does yet.
Excellent. Okay. Next question. Do you plan to integrate a logger that records the session for a full logged session?
So to do this via a kind of, strictly SSH-based tooling is reasonably tricky because you need to be able to intercept that session. You could possibly do it via some kind of scripting if you were to kind of configure your Bastion servers and then put some kind of scripts in place there where you could connect and it would maybe make the connection for you and then record the input and output of the session. I didn't add it into the blog post because one, the post was already pretty long, and two, honestly, it's quite a hard problem to solve like with SSH natively. I haven't looked in great detail into how to do it, but there isn't kind of an easy just turn on X option in the config and restart to make it work. So doing it with SSH kind of tooling natively is as far as I know, reasonably tricky. But of course, from a Teleport perspective, Teleport does do this for you. So Teleport supports session recording out of the box. So you can, and it supports that for either running Teleport on the nodes. So Teleport has a node service that resembles SSH as well. So it's SSH compatible and will allow you to do that. But also you can record sessions on your proxy, and Teleport will man in the middle those for you and record the session input and the session output. So you can get full session playback for all SSH sessions via Teleport if you configure it that way. So that would be, I don't want to sound like a shill, but that would be my encouraged way of doing it.
Excellent. All right. Next question. Is the support for a CRL URL included to avoid distributing CRL files?
So with Teleport itself, CRL and revocation is something we're still kind of working on. It's the built-in kind of expiry property is something that we're using to do that, but we are working on kind of actively being able to revoke certificates. For SSHD and for OpenSSH in general, you can sync a URL. I believe you can get your CRL, your revocation list, from a central location. So if you were to push that CRL up to like an S3 bucket or some kind of centralized storage, then yeah, you can have SSHD pull that CRL whenever anyone tries to log in and then use that to validate. That would be a good addition to the blog post actually to explain how to do that and how to set that up. But you should be able to do that. I believe SSH has support for pulling from a URL natively. Otherwise, you'd have to synchronize the file by some other method, and then you're kind of in the same position where you've got to push that list to all your servers, and you're not much better off than when you're using public keys. So yeah, definitely the URL would be a preferable method.
All right, great. Well, it looks like that's all the questions that we have right now. If you have a question, there's still a little bit of time, so you just use your GoToWebinar control panel and go ahead and get it on in. We actually did get another comment from Matthias, who was who asked about the time element question. He said it can be years out of sync initially. So
yeah.
It sounds like a typical problem.
I think so. I think in that situation, yeah, you'd have to have like a very long validity period on your certificates. So, but as I say, there are still perks to doing it and still benefits, namely the fact that you only have to sync one fingerprint out to your servers. You don't have to push, you don't have to update it every single time you get a new user. So you can do that, and that's definitely It's definitely a valid use case. So yeah, it's an intriguing use case though, for sure. Like embedded devices, I hadn't really thought about that. We get questions fairly often about how to do this for things like firewalls and switches, and kind of Cisco devices, Juniper, whatever. Anything that have kind of an embedded SSH service, but like a proprietary configuration interface or whatever. So you can, if they run SSHD, you can absolutely use certificates with those as well, but sometimes the embedded versions of SSHD that they run are not as fully featured as OpenSSH, so your mileage may vary, but definitely worth a try.
All right. Well, it looks like that is all that we have for the question and answer period. As I said before, if you have a question for Gus, we can probably slip one or two more in before we close things out. But even if you have a question after that, before the end of the webinar, you can certainly go ahead and use the GoToWebinar control panel and submit the question, because the folks at Gravitational are getting a copy of all the questions that are asked. And so if we don't address it here during the webinar, I'm sure they'll be more than happy to follow up with you offline and get your question answered. And while we are waiting, once again, I do want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or as I said before, if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we are sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on I believe it's the Security Boulevard website. So you can always go look for it there. Just go to securityboulevard.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, it looks like we don't have any more questions coming in, so I do want to thank the audience for so many great questions that did come in. I was very, very impressed at the quality of the questions.
Yeah, thank you.
So thank you.
They were good.
Yes, yeah, they were really great. And also, Gus, want to thank you for a great presentation, and also want to thank the audience for your patience as we worked through a couple of technical difficulties on this webinar. I think we pulled it off pretty well, but again, I do want to thank you all for your patience as we got through those. So I guess with that, this is Charlene O'Hanlon, and I'm going to go ahead and sign off now. I hope everybody has a great day, and please stay safe.